This is L by 4. This is L by 2. Can we calculate the tension and the reaction at the hinges? O, A, B, and C. A string is a vertical and a suspended block. Mass of the rod is m1. The way this is a block suspended by another string. Gravity is present. I want the tension and the reaction at the hinge. What are the forces that will be acting on the rod? What are the various forces that are acting on the rod? And I think all of you are able to see clearly. Go for free body diagram. So the question is, at equilibrium, find tension in strings and reaction at the inch. This is the inch. So straight away, the forces that are acting on the rod. If you find little bit difficult, go for one separate diagram. The weight m1g will act here. The reaction ry. And I don't take any reaction along x-axis. You must able to justify this. This is T2. This is T1 tension, and this is T2. What should be the T2? T2 should balance weight mg, no? M2g. And what about T1? T1 we don't know. And this is an inch. Write down all the equation now. Net torque about O, z axis should be 0. So for that, m1g L by 2 plus T1, sense of rotation clockwise, T1 3L by 4 anti-clockwise, T2 into L clockwise. T2 value we know. T2 is equal to how much? M2G. This is previous problem data. I'll write it here. You'll get confused with that. Now T2 is how much? Should be equal to, because for this to be in equilibrium. So now we know value of T2. We know mg. I'll get the tension T1. M1g by 2. 3T1 by 4 minus T2. So what is value of T2? M2g. L will get eliminated. Solving this, I'll get expression for T1. T1 should be 4 M1g check it. So this is T1. T2 already we got. What about the reaction? Ry. So now I'll go for Ry. What is Ry? Ry plus T1 minus M1g minus T2 should be equal to 0. So we know T1, T2, substituting here, we'll get it. So from where this equation has come, net force on the rod along y-axis should be 0. Why there is no Rx? Because there is no force acting on the rod along x-axis. Are you trying to look at? There's no force acting on the rod along x-axis. So therefore, there's no reaction. I think the problem, by this time, you should be able to understand. So the reactions everywhere, don't write Rx and Ry. Just do make observation. There are the forces acting on the rod along y-axis. So therefore, reaction. There's no force acting on the rod along x-axis. So therefore, no reaction will be there. Rx, in fact, in this problem will be 0. That's why I'm not showing. No reaction in the inch along x-axis. I don't have space here. I'll write it here. No reaction at hinge along x-axis. I think you have to be very careful about that hinge, all those things. System is in equilibrium, the net torque for individual bodies writing what happened will be more helpful. You can't write the for total everything. At system in equilibrium, you can write it, but you'll end up with more unknowns. Say, what is the purpose of writing equation? To get answer, unknowns should be eliminated. So if you write for the total system, like one problem with a cylinder rod, then you'll end up with more unknowns. No, you can't solve. If you don't want to get answer, then you write it. If you want answer, then you should break up the system because unknowns are more. No reaction at inch along x-axis. Okay, all these are problems. Tomorrow we'll go for some other set of problems. So only cylinder rod we took. No, tomorrow I'll bring triangular plate, quadrilateral plate, like a hemisphere, different structures. If they are in equilibrium, tension, friction, all will come. So tomorrow we'll conclude everything. This one torque. Okay, thank you all of you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.